As we have seen in the motor spec sheet, a multirotor requires a lot of current to fly. So where does this current come from? It comes from a battery, specialized battery known as a lithium polymer battery like this one. LiPo is short for lithium polymer. A LiPo battery can store and supply a high amount of current very quickly, making it suitable to be used in such applications of multirotors. Before we get into learning what is a LiPo battery and how to use them, a word on safety. LiPo batteries must be handled with care. If they get damaged a lot, the battery can actually swell up and at some point even burst into flames. Therefore, it is advisable to be gentle while handling lithium polymer batteries. Let's look at voltage of these type of batteries. A single LiPo cell has a nominal voltage of 3.7 volts. This number is what the manufacturers use, but it is not the maximum nor it is the minimum voltage at which the LiPo battery operates. The maximum voltage of such a battery is actually 4.2 volts. A single lithium polymer cell can go up to 4.2 volts and can go as low as 3 volts. If more voltage is required, then we can just connect multiple cells in series. So as you can see here, this particular battery has 3 blocks here. So these are actually 3 lithium polymer cells connected in series. Therefore we call this as a 3S battery. S stands for series. Similarly, this one here is a 2S battery. It has 2 cells connected in series. Since a single cell has 3.7 volts, a 2S battery has 7.4 volts. As you can see, it's written here. And just like that, this 3 cell battery has a voltage of 11.1 volts. It's mentioned over here. Similarly, we have also 4S having 14.8 volts and so on. More the cells in a lithium polymer battery, the faster the motor will spin because the voltage is more. But that also means a heavier battery because there are multiple cells in it and each cell adds up its own weight. The battery should always be used between 4.2 to 3 volts. However, it is advisable to stop around 3.7 volts for keeping the battery in good condition. Going below 3 volts can cause permanent damage to the battery, and overcharging above 4.2 volts can cause the battery to catch fire. Now let's talk about the battery capacity. It is given in milliamp hours, as you can see on this one. So this battery has a capacity of 450 mAh. So mAh stands for milliamp hour here. For example, if the capacity of a battery is 1000 mAh, it means that if you draw 1000 milliamperes of current from the battery, it will take about 1 hour to drain the battery completely. More capacity can give you a longer flight time, but it also increases the weight of the battery. Note these trade-offs. As you increase the capacity, more will be the weight of the battery and heavier it will be. Next thing to look at is the C rating. So here you can see there is a C rating of 65C. Here you will find a C rating of 35C. C rating indicates the maximum rate of discharge the battery supports. We can calculate the maximum rate of discharge by multiplying the battery capacity with the C rating. So for example, if a battery is of 1200 milliamp hours with a C rating of 50C, then the maximum discharge rate of that particular battery will be C rating multiplied by mAh, that is 60 amps. Let's talk about the battery connectors. All lithium polymer batteries higher than 1S come with 2 connectors, that is a discharge connector and a balance connector. This yellow connector is called as the discharge connector, and this one, the white one, is called as the balance connector. There are also smaller connectors like this one. So this discharge connector is called as an XT60 connector, and this one is called as an XT30. So they mainly indicate how much current they can handle. So for example, this is a bigger one, it handles more current than this one. Now we have something called as a male and female connector. So this here is a female connector, and there is another connector where the battery connects to the drone, and this one is the male connector. So batteries usually tend to have a female connector, and they simply plug into each other. The balance connector is used for checking the voltage of each individual cell in the battery. This is because all cells have to be roughly at the same voltage. The balance connector helps in charging the battery. The charger checks through the balance connector if the cells are at uneven voltages and then proceeds to make all the cells at the same level. This is called as balance charging. The balance connector, as you can see here, has one more wire than the number of cells inside it. So which means that this here is a 4 cell battery. We'll see another example. This is a 3S battery and the number of wires on the balance connector are 4. That is 3 cells plus 1. So let's take an example of how you can select the right battery for your drone. Let's say we have a quadcopter like this one. It has 4 motors, and from the spec sheet we found out that each motor requires maximum of 30 amps. Since this one has 4 motors, we have to multiply 30 by 4. Therefore we get the value as 120 amps. In reality, the actual current is going to be lower than what is mentioned in the spec sheet, as these tests are done on a desk. Also consider the fact that how often are you going to fly at 100% throttle. You will normally be flying at 40 to 80% only. So a battery having 1600 capacity and 90 C rating. So we multiply the mAh by C rating and we will get 144 amps, which suffices the requirement of our drone at 120 amps. If you are wondering about how to select the proper voltage, then the voltage is usually mentioned on the motor spec sheet, that a particular motor will support either 2S, 4S or 3S. For 5-inch drones, you will tend to prefer a battery of somewhere around 1000 to 2000 mAh like this one. This here is a 2000 mAh battery and weighs about 200 grams. For big multirotors, you might want to go around 5000 or even more. One thing that you will notice when flying the drone is that when the drone rises up, the voltage drops immediately. But if you bring the drone down, the voltage will start rising up again. This is because the motors are using up the extra voltage to go up. So once it is down, the motor starts spinning slower and that much voltage is no longer needed. Therefore you might have an illusion that the battery is charging itself. Another thing you might have noticed is that we did not consider about other components on the drone. We only looked at the motor current requirements and we calculated the battery required. But there is a reason why we did that, because amount of current like 30 amperes is drawn by the motors, and as compared to that anything else is negligible. But to be on the safer side, you can always add 1 or 2 amps to the calculation. Now let's look at how you can charge a LiPo battery. So since this one here is a 450 amp, so we'll take an example of this one. So LiPo chargers, you can set the current at which the battery charges. Normally we charge a battery at 1C, that is if the battery, for example here, is 450 mAh, therefore we will be charging this battery at a 0.45 amps. If the battery was 1600 mAh, we would set the current at 1.6 amps. So it will take around 1 hour to charge the battery at 1C. So theoretically, to fully charge any battery at 1C, it will take 1 hour. And remember, overcharging the battery can be dangerous, even though LiPo chargers do have a feature that stop the charging process once the battery voltages reach 4.2 volts. And it is a good idea to always keep a close eye while the battery is charging. So how to dispose a battery in case if the battery is no longer useful? If let us say your battery swells up or it starts leaking some of the chemical that is inside. So what do you do next? One thing you can do is you can cut off these connectors. So we cut off the connectors only to reuse them. Then you can put the battery inside a salt solution. So by salt solution I mean a bucket of water mixed with salt, and you can keep the battery in there for a few days. So that will discharge the battery, and then you can bury the remains underground. Storing of LiPo batteries. Always while not using the battery, if you are not using it for a month or so, then you will have to keep the batteries at 3.8 volts per cell and store them in a special LiPo bag. So this here is a special LiPo bag. So it is made up of a fireproof material, as you can see. So this type of bag is used to store batteries. So keep the battery voltages at 3.8 volts per cell and put them in such type of bag at room temperature. If at all you encounter a LiPo fire, then use a fire extinguisher. You can also use sand, but do not use water because it is an electric fire. It can be dangerous to use water on it. They produce a lot of smoke when it catches fire, so don't breathe in that. A replacement for a LiPo battery can be a lithium ion battery. They tend to be much more safer than these type of batteries. But the manufacturing of a lithium ion battery having high C is quite difficult, and there are not many manufacturers that do that. That is it about lithium polymer batteries in this video. In the next video we will be learning about flight controller.